Hello everyone. In this lecture, this is the third week. I am going to cover today some central tendency, that means mean, median, mode, and then measures of dispersions and their explanations, how we can explain them. So mean is the average of the all data points. So this is known as more specifically arithmetic mean. So if someone asks me, this is known as the mean or arithmetic mean, ARITH, arithmetic mean. So arithmetic mean is definition this x bar sum of xi over n given all the data points. So how can we compute the mean by using R and Excel? Let me show you. This is the R, and as I have shown you the data, this is my data head. Head means first 6 row empty cars. Empty cars is the built-in data that comes along with R. So empty card data, suppose I want to find the mean of the MPG variable. If I write here mean and then write here empty cars, which is the name of the data, and dollar sign is the separator between data and variable. So our variable is MPG. So if I write it in here, I got the mean is 20.09. On the other hand, if I want to see the mean of distance, so this is the mean of that. If I want to find the mean of the horsepower, so HP, then this is the mean. So this is the way we can find the mean. This mean is known as the arithmetic mean. Now the next question is, suppose I have given data in this format. Let me open a Word file, blank Word file, and then insert multiple of those pages. So if this is the data point 2, 5, 9, 6, 7, 10, how can I find the mean? The mean is known as the x bar equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6 divided by 6 observations I put here. So here x1 equal to 2, x2 equal to 5, and then it will go and stop in 10 divided by 10 divided by 6, and then you will get the result here. These two equal to 7 and this equal to 16. 16 plus 6 equal to 22, then 32, 32, 39. 39 divided by 6, so it is if I do 13 divided by 2, so 6.5 is the mean. So if someone asks me to find this mean by using R or Excel, what can I do? I can do it. So I can write here D1 stands for the data, and I can put here equal sign, and then C is the concatenation, then 2, 5, 2, 5, 9, 6, 7, 10. 9, 6, 7, 10. And then if I put here mean, and then you will get D1 equal to 6.5. How can I find this as a mean for by use how can I find the mean by using Excel? So in order to find the mean of the x by using Excel, let me open an Excel file, and this is the Excel file, and then I just want to paste it in there. So data has been pasted in there. So if data has been pasted, I just need to get rid of that. And then I have this data. These data I selected, and home. Where is that? Oh, let me go to the data, text to column. So just go there and then comma, and then data has been separated into 6. So now if I want to find the mean, I have to write the average, and then I want to select all of this and hit enter. 6.5 is the mean. So this is known as the arithmetic mean. But the question is, suppose if I have been given data in this format, xi and fi. So xi equal to 2, 2 is appearing 10 times. Xi equal to 3, xi equal to 3, it is appearing 5 times. Xi equal to 10, which is appearing 2 times. Xi equal to 7, which is appearing 3 times. How can I find these things? How can I find the mean of this distribution of the x where data comes in the format of the frequency for each value of the x variable? In such a cases, formula to find mean is sum of fi xi divided by sum of fi. So sum of fi equal to 15, and then 520. This is equal to that. And here 2 times 10 plus 3 times 5 plus 10 times 2 plus 7 times 3. And then if you find this mean, the mean will be 2 times 10. So you can find here, let me find it in R. 2 times 10 plus, where is that? 2 times 10 is 3 times 5, 3 times 5 plus 10 times 2 plus 7 times 3, 7 times 3. And then if I want to divide it, then it should be division by 20. And this is the answer, 3.8. This is the way you can find the answer. So this is the way, this is known as finding the mean of a variable where data is given in the format of a frequency table. Okay, this is the data is given in the frequency table. So we have learned how to compute mean for uh, uh, by using paper and pencil, by using Excel, as well as by using R. Okay, so now you remember I discussed histogram. Histogram is constructed for the quantitative variable, numerical variable, either integer quantitative variable or continuous quantitative variable, which take fractional values, that means decimal values. Okay, so after constructing histogram, if you add the top middle point of each bar, and uh, then if you get the curve like this way, this is known as the skewed to the right, because in this case we see a long right tail. In such a cases, this is the peak highest. So that means in this point, highest frequency exists. So this is known as the mod. Mod is the value of a data set which appears maximum number of times, which has the highest frequency, mod. And median is always in the middle. Remember, median is always in the middle. And here is mean. Here is mean. So why I draw this curve and locate mean median mode? Because in such a case, when you have a quantitative variable, quantitative data, you construct the histogram and at the top middle point of each bar, got the smooth frequency curve. In such cases, if the curve show long right tail, which is known as the skewed to the right or positively skewed, in such cases, median will always be middle and highest peak will have a mod and extreme right tail will have a mean. Now, you could ask me why. If this is your question, why this? Why not in other way? Why not mean in the middle or mean in here and more in there? Why this way? Why should we believe you? If this is your question, the answer is, suppose you are collecting data from Hattiesburg area. Okay. This Hattiesburg area, you are collecting data about yearly income. So yearly income is Hattiesburg area. It ranges from maybe 25,000 to on an average maybe 100,000, something like that. Okay, 25K to 100K. So you went, suppose 200 people. 200 people you went, and more, these 200 people you went and you asking how much you make per year. He said I make 23K. Another said I make 47K. Another said I made 110. Another said I make 41K. So this is the way, maybe 30. Okay, but in such a 200 data points, suppose 2 or 3 people are included who are making 2.3 million and one is making 5 million. Okay, so just out of 300 200 data points, 10 or 15 data points that has a very high value. Because of this high value, the mean drag to the right, that means mean value increases. So that is why the mean is increased here. Okay, or more specifically, you are collecting data from a county where most of the people are middle class or poor, but if some rich people with huge yearly income are included in your data, in such cases mean will increase, mean will inflate. In such cases your histogram and the frequency curve would be positively skewed. So that's the reason why mean is in the right. Exactly opposite way, suppose you went to collect data from Beverly Hill. Okay, in the Beverly Hill, all the celebrities, their income is $1 million, 1.2 million, 2.5 million, 6.5 million. These are all million people, and you are collecting 200 data points. Among these 200 data points, suppose 15 or 16 data points are included from the plumber, from the Uber driver, from the maid, and from the electrician, and from the people who work as a like manual job or job. In such cases, so they will drag the mean to the left because they will reduce the mean. Okay, so in such cases, most of the people Beverly Hill, their income is high, maybe 1.2 million mod is this is their yearly income, but few people who are plumber, who are like technician, who are Uber driver, who are working as a maid or maybe school teacher or nanny, their income is low. So that is why they drag it to the left. So this is the place of the mod. This is the mean. They drag to the left, and median is always in the middle. Okay, median is always in the middle. So this is what I have discussed. And when you construct the histogram and add the top middle point of the each bar and got a curve that is like this is known as the bell-shaped, bell, bell-shaped or mound-shaped or symmetric, bell-shaped, mound-shaped or symmetric or normal curve. Normal curve. Okay. So in such a case, in this place, mean equal to median equal to mean. Okay, after these discussions, let me take you to the next slide. Let me take you to the next slide. Mean is done. Now median equal to what? Median is the middlemost point. Middlemost point, let me put 6, 7 numbers like the 10, 5, 9, 16, 13, 8, 5. Okay. So these are the number. I want to arrange them in ascending order. 5, and then again 5, then 9, then 10, then 13, then 16. Okay. And 13, 16. There are 1, 5, another 5, and there is 9, 10, and then 8. There is another one is 8. So in such a cases, this is the middlemost observations. So this is the median. Median is the middlemost observation. Okay. Median is the middlemost observations. So now suppose in a state of 7 observations, suppose there is another observation, suppose which is equal to 12. In such a cases, I have to arrange it 5 and then 5 and then 8 and then 9 and then 10 and then 12 and then 13 and then 16. So now 4 observations, right? There are 8 observations. So that means you have to find the average of these two, which is equal to 9.5 is the median. Okay, now for this data, how can I find the median is the middlemost observations. 50% of the observations falls below the median and 50% of the observations falls above the median. So now this is the median is staying in here, which is equal to 9.5. So now the question is, how can I find the 25th percent? This is the 50th percentile. Okay, median equal to 50th percentile. So 50% of the observations fall below median, 50% of the observations falls above median. So this is the 50th percentile. Now after this 50th percentile, let me explain you what is quartile. So this is the first half. Okay, and this is the second half. Okay, in this first half, find the median. So, and then that median, this is called the 25th percentile or first quartile. 25th percentile or Q1 first quartile. First quartile. Quartile. Okay, and similarly, this is the second half. This is the second half, right? If you find the median of that, which is in here, 12 plus 13 equal to 2, which is known as the 75th percentile, or the Q3 known as the third quartile. Known as the third quartile. Okay, so you have understand how to compute median, how to compute Q1, how to compute Q2, how to compute Q3. This Q1, Q2, Q3 and median, this would be used to construct box plot that I already discussed in my previous slide. Okay, so you understand the median. After median, if I want to find the median, let me go to that place. If I want to find the median, if I write here median and then just add this, hit enter, 6.5 is the median. Why? Because 6.5 to 5, 6, 7, 9 and 10. So 6 plus 7 divided by 2 equal to 6.5. So that is why this is the median. How can I find the median by using this? Let me check median and then empty cars is the built-in data, dollar sign is the separator. If I put here HT, okay, it is not coming median. Okay, HT, no, HP. Let me put here HP. So 123 is the median. That's the way you can compute your median. Okay, after computing median, now let me take you to the next slides. Next slides. Mod I already discussed. Mod is the value in the data set which is appearing highest number of time. In a data set, if there is only one observations that is appearing highest number of time, then this is called unimodal. Let me write it. That is called unimodal. Unimodal. That means unimodal class. If there are two observations which are appearing highest number of time or same number of time, then that is called the bimodal. Bimodal. If they are in a data sets, if there are three observations that are appearing same number of time, that is called the trimodal. Okay. And now let me discuss about the geometric mean. Geometric mean is the multiplication of the observations uh, by its if there are n observations, multiply n of them and then take the one nth root, take the nth root. So that is this is the geometric distribution definition. For example, if I have data like 5, 2, 9, 6. Then how can I do? I have to do 5, 2, 9, 6. That means 10, 54. That means 540. And then it is 1 over 4. 1 over 4. 1 over 4, that is the geometric mean. Geometric mean is used in order to better compute the growth rate. So growth rate in financial analysis, in order to compute the growth rate, this has been used. So there is an example, read it. If you do not understand this, let me know. I will explain these things. But there is also big limitations for the geometric distributions, because if one of the observations that I showed in here, if one of the observations is 0, then entire multiplication will be 0. If growth rate in a particular year is 0, then entire thing is the 0. If growth rate could be negative, so that means return is negative, then entire thing will be negative. And you know, the one negative sign cannot handle by the square root. Any negative sign under the square root will give you complex number. Okay. I. What is the definition of I? I equal to square root of -1, right? So if you are asked to compute geometric mean, but in the data there is a 1 0, that means all multiplication will be 0. 0 is so dangerous. It can make anything 0 if you multiply it. Okay. If you argue with me, I can give you the example why 0 can make everything 0 when it is multiplied. I have a very good explanation for that. And if there is a negative number, then entire thing will be negative. Okay, let me quickly give you why 0 is so dangerous and 0 make everything 0. So suppose there is a 100 times 1, 100 times 1. So that means 100 times 10 equal to 1000. Okay, and then 100 times 1 equal to 100. Okay, now 100 times half equal to 50. Okay, now 100 times 0.10 equal to 10, right? 100, if you fix any number and then another number, if you go one after another, then it is, are you saying it is 1? Then if you multiply it by 0, 0, 0, 0, 0, then what? It will be very 0, right? So similarly, if you go down more close to 0, then it will become 0. Okay. Similarly, anything divided by 0 will give you infinity, very big number. The rationale is the same. Okay, so I think I have give you good explanation of why geometric mean, where geometric mean is used, how it is computed, and what is the big limitations of the geometric mean. Okay, now the new topic that I want to discuss about is called the variability. So in order to discuss variability, let me explain these things by this example. So suppose there is a group one, that group is known as the group one, and this is the another group, that group is known as the group two. Okay, group one and group two. This group has a mean of 50 and that group has a mean of 50. Okay, this group has a mean of 50 and that group has a mean of 50. And if you understand, uh, like if you are asked, there is a group of 4 students, their average, sorry, let me erase these things. There is a group 1 and there is a group 2. Okay, and the average of the first group is 50 and the average of the second group is 50. First group has 4 students and second group also has 4 students and their average is 50. What would be your immediate opinion, or what would be your immediate thought about the two groups? You will say that, well, first group has a average 50, second group has a average 50, so both groups are the same. This would be your immediate intuitions or intuitive answer by looking. But if I give their individual number of the 4 students, suppose this is equal to 50, this is equal to 49, this is equal to 51, this is equal to 50, and then if you add them up, the average x bar equal to 50. Okay, now if this number is given to you, one is 100, one is 1, one is 0, one is 99. Okay, now if you find the average for the second group, this is also 50. Okay, now by taking a look at the individual data point for each group of size 4, you say that first group has consistent data, second group has extremely high value and extremely low value. This is the individual exam scores for a group of 4 students. This is an individual exam score for a group of another 4 students. So now you immediately say that first group is a group that that consists of students with average quality, average something like that, or below average. But second group is a group of students which consists of extremely good students and extremely poor students who perform poorly in the exam. So this is what you immediately answer. But you cannot you can answer these things by visualizations of the individual data points, which is a small 4, but you cannot come up with this decision when data size is 5,000. Instead of 4 data points, if first group has a 5,000 data point, second group has a like 6,000 data point, how can you come up with the decision that one group has a higher variability compared to the other? You cannot. So in order to do that, a measure need to be introduced, which is known as the standard deviation. So take a look at the measure. This is known as the standard deviation, denoted by S, and it is written as 1 over n minus 1 sum of xi minus x bar square, and this is the way you can find it. Okay, standard deviation. So if you compute as standard deviations for the first group and standard deviation for the second group, then you can say that, right, first group has a more consistent data compared to the second group because the standard deviation is smaller for the first group compared to the second group. Okay, now let me take you to the Excel and R, and we want to compute this small example very quickly. Control L, everything clear. So now go to the group 1 Z1. I have a data which is 50 and then 49 and then 51, and then 50. This is a first group of data, and then Z2, which is a second group of data known as 100, 1, 0, and 99. Okay, now take a look at the mean of the first group Z1 equal to this mean of the second group Z2, mean of the second group Z2 equal to this, and SD of the first group Z1 equal to this, SD of the second group Z2 equal to this. So see, second group has a very high variability compared to the first group. Second group has a very high variability compared to the second group. For the big data, you have to compute standard deviations in order to show which one has a highest variability. Now, what is the definition of standard deviation? If someone asks me, could you verbalize? Could you verbalize these definitions? What is the definition? Someone asks me question. I want you to verbalize these definitions. Verbally speak. How can you write this? Okay. See, I am writing. Average distance, let me write it. Average distance of each data point from its average. Average distance of each data point from its average. So see, average distance. So this is the distance and divided it by this. Each data point from its average, this is this distance of each data point from its average. So this part, distance of each data point from its average is this. I'm squaring it, I'm neutralizing it, and then dividing it by the n minus 1. Even though I am summing here n terms, I'm dividing it by n minus 1. That is another story. That is called the degrees of freedom, as well as number of independent observations. So those are the other thing, but this is the definition: average distance of each data point from its average. This average is because I'm finding the distance and dividing it by n minus 1, whatever quantity I'm getting there, and then squaring it. Okay, so now if I have a data point like this that I mentioned in here, in this data point, if I ask to find the range, what I can find the range for highest value is 51 and lowest value is 49. So our range is 2. In this case, range is the difference between highest and lowest value. 100 minus 0 equal to 100. Okay, 100 minus 0 equal to 100. This is what we have found. Okay, after that, let me see the measures of variability. I have explained those things to you. I have explained range. Variance is the square of standard deviations, which is just the square of the standard deviations. Now for Excel data and R data, suppose I have this data, head, empty cars, and then if I am asked to find the SD, if stand for standard deviations, empty cars, dollar sign, MPG, this is the standard deviation. Okay, this is the, and then if you put instead of SD, if you put var, then you got variance. So you got standard deviation and variance. Okay, you got standard deviation and variance, and then standard deviation and variance is done. Now coefficients of variations. So coefficients of variation is nothing but the expressions or percentage expressions of the standard deviation with respect to mean. So with respect to mean, the percent uh, percentage of standard deviation with respect to mean. Okay, so the coefficient of variations usually expressed as percentage measure how large the standard deviation in relatives to mean. Uh, for example, take a look at that. If I want to find that way, I want to find that way, Z1 and then Z2. Okay, so now if I want to find SD of Z1, SD of Z1 divided by mean of Z1, mean of Z1, and then I want to express is in terms of 100, then this is the result. And then if I want to find it in terms of like this, then this is what. So second one, with respect to mean, the variability is not that much. If so, with respect to mean, variability is not that much because it is close to 1. Take a look at that, close to 1. But with respect to mean, the variance is very high. So here we are using the same mean, but variance is different. So that is why. So if I ask you in the question, give an explanation or a short definition of coefficients of variations, then you will have to explain that coefficient of variation expresses standard deviation in percentage with respect to its mean. So that's the explanation. Okay, so let me quickly check and 2.7. Okay, 2.7 in another. So let me stop in here. I guess let me go there. Stop recording. I stop recording.